Hello, guys. Let's start the next session. Today, I'm going to talk about LockerService. My name is Marat. I work for Salesforce, obviously, as a lead application security engineer. So I deal with a lot of security challenges in Salesforce applications. And in particular, today, I'm going to present one case that I solved personally, just specifically for this talk. So in this talk, you will learn how to structure your JS-heavy project while using Salesforce DX. I'm sure many of you are not familiar yet what Salesforce DX is, but if you're not, then you should get your hands dirty, trailhead on it. It's a very fancy way of developing Salesforce applications. Then I'm going to show you how to develop JavaScript libraries for your Salesforce DX project using Webpack, so it's LockerService compatible. And on top of that, you'll learn how to use your classic JavaScript tooling, not Salesforce specific, with your Salesforce project. So let's do a quick show of hands. How many of you actually used a third-party library in JavaScript and it broke under LockerService? Wow, that's a lot of people, right? So I'm familiar with this problem, and I was always curious what's the root cause of this. So I went to salesforce.stackexchange.com and took the first question in that list, is like, why are these libraries broken? And the answer to that question was this. So go to this article. You can access this article using the short URL. This is the list of Salesforce tested JavaScript libraries. Use those. If it's not on the list, then you're out of luck. So remember this article. I don't know if you ever read this Locker article. Forget it now. You won't need it anymore. So I'm going to show you how to fix almost any library without code modifications. And to do that, I chose the top question. It was some random library choices, JS. It's a tiny library that allows you to do some kind of input text box. I tried to put it into LockerService enabled page and component, and it just failed with some cryptic error message. I had no idea what it actually failed at. So I opened the source code of the library, and you see that it basically uses very old polyfill for Internet Explorer that adds capability of custom events to the browser. And they assign it to the window object, which is LockerService, a secure window, which is already polyfilled by carefully designed code. It messes up this object, and it stops working. Actually, the truth is, even if you were using this app without LockerService in like normal app, it would still break because you should not use Internet Explorer polyfills in the browsers that actually do support custom event. So let's apply some Salesforce DX and Webpack magic to fix that. To do that, I'm going to introduce the modern development Salesforce stack in 2017. So all like cutting edge technologies, all hipster stuff. So you package your application using Salesforce DX, similar way to Heroku. You use Lightning components and Salesforce design system, which is a UI, UX components for your lib. You enable LockerService for security, obviously. And even on top of that, I enabled a critical update, which is not enabled by default, is a stricter CSP, content security policy. So I enabled all features that could potentially break anything at all, and I still managed to develop this library. Moreover, I wrote it in ECMAScript 6, used Webpack to pack it, Babel to transpile it to browser-compatible JavaScript. And on top of that, I linted it so it's compatible with Salesforce APIs. So let's go back to exhibit. So Salesforce DX produces artifacts. We know you guys love artifacts, so we put an artifact inside of your artifact in this sense. So you have your Aura code, your classes, your objects, layouts, whatnot. All your custom Salesforce code under Salesforce DX is called artifact. So inside of that artifact, we're going to put static resources, and these static resources are, we call it Webpack artifacts. So we'll have two projects. One project is for your Salesforce code on top. You don't have to read through the text. It's just I'm showing this overall structure. So on top of that, you have your Lightning component that has your custom Apex code, layouts, whatnot. And at the bottom of it, you have your custom JavaScript stuff that compiles into your Salesforce DX project. What we are going to do is just configure Webpack to do these 5 things. First, get your JavaScript together, transpile it, build one big bundle, and ship it inside of your Salesforce DX project. Package the code so it correctly exports the library. Fix all Locker broken things. Lint it for Lightning issues, and transpile it to browser-compatible JavaScript. I'm going to show you the pieces of code. You don't have to read into that. In the last slide, there will be URL, so you can access all the code snippets there. But I'm just showing it, explaining what it does. So first, you have to configure your JavaScript output. As you can see, I specify the output path to this Salesforce DX project folder, and I call it app resource, which will hold all my JavaScript, all my custom JavaScript for my controller. And I export it under a global variable called my controller. Same thing for CSS. Majority of third-party components, if it's UI UX component, they have some custom CSS files. So what you want to do is take all the CSS files and compile them in one big CSS file that will be shipped under styles.resource. So you take them all, you apply this extract text plugin for Webpack, and it produces beautiful styles resource file properly extracted. So now to the main part of this talk. So if you look at the code above, it shows you a code snippet that will definitely break under LockerService. The main reason behind that is because of use strict CSP, use strict and CSP that is a part of LockerService. So if you reference this variable in JavaScript, but you mean window, this will break. And that's actually a correct behavior because this behavior is kind of deprecated. You should not use this when you mean window. What you can do in Webpack, you can just say, wrap this whole thing into a function call that will bind this to window, so you don't mean window by this anymore. And it's done with using these lines of code at the bottom of the slide. Super easy. So what happened with choices.js in particular, though, so it messes up the window object. What we want to do is we want to protect the window object and from this messy library. So I wrote my custom loader called Un-polyfill loader. It's in the demo repository that you will see in the last slide. Basically, what this loader does, it stores all LockerService window objects, runs the library, and restores them back. So whatever this library might do and break, it just gets recovered after that. So you don't have to worry whether this library actually messes up your window object with polyfills or anything else. It will restore them for you. At the bottom of it, I specify the directory for custom loaders so that my custom loader gets loaded. Another issue is that some libraries use UMD and AMD styles of imports. If you don't know what it is, just to give you a brief introduction, you basically don't want to have them because they have a fancy way of importing stuff that is not compatible with LockerService. So they basically reference window as this variable as well. And for AMD packages, Webpack does not like them either. So what you want to do is specify one more line of code that defines that redefines the variable defined to false. But long story short, even if you use these libraries, you use Webpack, it kind of wraps them nicely anyway, so you don't have to worry much about incompatibility. Another thing, you probably want to develop your app in a modern JS, so you want it to be in ECMAScript version 6 or 7, but at the same time, you want to maintain older browsers. So your output artifact should be in ECMAScript 5 or browser-compatible version. So for this, you use baby loader. So you take the JavaScript file and transpile it using baby loader based on your environment setting. Your environment setting, though, should be last 2 versions of browser list. So like all modern versions of Chrome, Firefox, Safari should be supported. You could also add Internet Explorer 11. However, I strongly encourage you to go to this URL and verify the support dates for Salesforce product for each particular browser. So your configuration should match that. But easy to remember configuration setting is just support last 2 versions, and that's it. Internet Explorer 11, you can add support for it, but truth is LockerService is not enabled in Internet Explorer 11 anyway, so you don't have to worry about it too much. Another part is that if your custom code actually does something with global variables that are exported by Lightning and LockerService, then it probably will break. So I just open sourced a new plugin for ESLint. ESLint is a code quality tool for JavaScript that will complain about your code if you do something not Lightning compatible. You can access it in NPM under ESLint plugin Aura. So just to demo this, you can see this choices.js now does not produce an error, and I don't know why would you use such an input in your app, but apparently some people want to use this. It works perfectly under LockerService. I did not change, the important part, I did not change any single line of code of this library. So I only used Webpack to configure environment for this library, so it's shipped as an artifact beautifully under my Salesforce DX project. The projects I just open source, so you can access in NPM if you use the ESLint. So it's a ESLint plugin Aura ships you custom rules for ESLint and Lightning APIs. Under this URL, it's a demo code that I just showed in this slide, so you can check out the whole Salesforce DX project that has this choices.js component. It has 2 components. One is like a pure choices.js, which is broken, and another one is choices.js packed with Webpack, which is clearly working. If you still develop for VisualForce, you should check out my other work, which is not relevant to this talk. Is also ESLint plugins, but for VisualForce. So it fixes your security issues in your custom JavaScript in VisualForce. If you're interested in security, then you should also attend these 2 talks after me, so 1:30 p.m. and right after that, 2 p.m. My colleagues will introduce you to open redirect and cross-site scripting, SOCL injection in CSRF. And with that, I'm ready to take any questions. I'm going to put the slide with the projects here, so you could take a memo. Any questions? OK. And that's it from me. Thank you.